Alright, the next part we're going to go into is we're going to start out in the graphing quadratic equations. We're going to take this little bits at a time, so there's going to be multiple videos for this part. The first part, they have this, we have a bunch of vocabulary terms. We're not going to go through all of them, we're just going to go through a couple today, and then with this video, and then we'll add a few as we kind of keep going, okay? Excuse me. So first, the first one is a quadratic function, and if you remember back to our graphing unit, right, we talked about functions, and functions basically look like, if you remember, we had y equals, oh, that's not a good color, y equals, in the old, back in the old unit, we had y equals mx plus b, okay, and we called that what? Slope-intercept form, right? And it was a function because it had y equal to something, and what you would do is put x in there, and you'd put a number in for x, and whatever you got out was y, and that's a function. The y is determined by what x is. Okay, and so quadratic function is basically the same thing, except for it's quadratic, meaning it's got a little squared in there. Okay, so that's what x squared makes it quadratic, remember? Okay, the x by itself makes it linear, the x squared makes it quadratic. Okay, and that actually leads us into the next point, which is parabola. And a parabola, hopefully you guys have actually seen them before and heard of them, but if not, a parabola, basically what it is it's the graph that you will get when you have a quadratic function. Okay, now when we were doing our graphing in Unit 3, we were dealing with linear functions, so they made lines, right? Well, in a quadratic function, it makes a parabola, and a parabola looks kind of like a U, okay? Or it's like kind of in between a U and a V, okay? And it'll come out kind of in this shape like that. Oh, I'm making a little happy face over here. I'm putting a little nose in there. There you go. Okay, no, the nose is not part of the drawing. Okay, the parabola is just a little U shape. It could be that way. It could also be that way. Okay, the vertex, okay, is the lowest of or highest. It should be or highest point on a parabola. And so the two parabolas that I've drawn right there. Let me get a good color. The two colors. Sorry, the two parabolas that I've drawn. The very lowest point would be that little point right now. Whoa, it's not very good. Okay, the lowest point of the parabola and the highest point, so that would be the vertex. Okay, so yeah, that's what a vertex is. It's the lowest point if it's opening up, and if it's opening down, it's the highest point. Okay, and then the next one is axis of symmetry. And if you remember way back, a couple years back, okay, and we've talked about it here and there, but they taught you about symmetry actually all the way back in kindergarten, if I remember correctly. Symmetry just means whatever's on one side looks exactly like it on the other side, right? Okay, so the axis of symmetry means it's the line, okay, that makes both sides mirror each other. Okay, now obviously my drawings aren't very good, okay, but basically there's a line that kind of goes straight up and down the middle, and the left side and the right side look exactly the same. Well, that line that divides it, that's the axis of symmetry. Okay, so these are all terms you're going to need to know relatively soon, so I wanted to make sure that you knew those before we moved on. Okay, now as we go through this, we're gonna just, I wanted to cover those couple vocab terms. We'll come back to those later on, and then now what we're going to do is we're going to move into how to graph just like basically anything, even a linear equation. You kind of use this first type of solving, okay, and how to graph it. So we're going to move into that next. Okay, so let's move into some graphing here. All right, first of all, so you have some steps, and basically when you do it this way, it'll work no matter what. Okay, so no matter what, you can use this method. Sometimes it takes more work. It just kind of depends on the problem. But no matter what, this always works, and this always works even if you have like linear equations, which we talked about earlier. Okay, we've done this before, and basically it's kind of like a t-table, right? So you have your x, And then if you remember, instead of a t-table, I made it like a little field goal, and then you would get out a y, and in the middle you would put your problem. So in this case, we have y equals 2x squared. Okay, and basically what you're doing here is you're just going to pick some values for x. You're going to plug them into the problem, and then you're going to get out y. And then when you're done, you connect all those points, and you should have the graph. Okay. Now here's something to remember. Okay, when you have a quadratic function, the number that is the coefficient of the x squared, okay, or the quadratic part of it, if it is a positive number, okay, your parabola is going to open up. If it is a negative number, your parabola is going to open down. Okay, so this is something that you want to get in your head, and basically anytime you have a function, you should be able to look at it right away and go, okay, what's the coefficient for the x squared term? And if it's positive, you know it's going to open up, and if it's negative, it's going to open down. Okay, so you should know that right away. So in our problem we have right here, we have y equals 2x squared. So we know that that 2 is positive, so that means that this graph is going to open up. Okay, and now all we have to do is pick some terms. So for x, I'm going to put the first one as 0, and y equals 2 times 0 squared. Okay, that's not a very good squared, but you get it. Well, 2 times 0 is going to be 0. So 0, 0 is our first point. Okay, and I'm going to put it on my graph over here. Okay, how about we choose 1? So for x next. And if we put 1 in there, 2 times 1 squared, that's just going to be 2. So at 1, we go up 2. There you go. Hopefully you guys remember your graphing. My pen broke, so I'm using a not so great one today, so I apologize for any missed dots. I'll just do the best I can. Let's try negative 1, see what happens. Negative 1, for x, you put negative 1 squared is positive 1, and 1 times 2 is 2. So at negative 1, we go to 2. Okay, and then we'll go 2. So 2 squared is 4, times 2 is 8. So at 2, we go all the way up to 8. So that's right there. Okay, and then if we put in negative 2, same thing. Negative 2 squared is 4. 4 times 2 is 8 also. So negative 2 up to 8. Okay, and you can kind of see here, right? See, if you connect these points, okay, this is kind of harder to draw, but you connect the points, you'll notice, okay, we get a little U shape, UV kind of in there. Okay, and if you look, right down the middle, okay, if my drawing was a little bit better, there we go, that's a little better. Right down the middle there, right on the axis, that would be our axis of symmetry. Okay, so our graph would continue to go this way, and right down the middle is our axis of symmetry. Okay, and our axis of symmetry hits at x equals 0. Okay, so when x is 0, that's where our axis of symmetry is. Okay, so hopefully that kind of makes a little bit of sense to you. Look at the next example. Let me switch page here. Okay, our next example, y equals negative x squared minus 1. And so if you look at that right now, the coefficient for the x squared, it says negative, but if you should know, right, it actually means negative 1, right? So negative 1 times x squared. So our negative 1, that tells us that our graph is going to open down, okay, because it's a negative coefficient before the x. Alright, so let's plug in some values. So 0 for x the first time. That's an ugly 0, but we'll take it. 0 in there, that equals y equals negative 1. So at 0, we go to negative 1. Okay, let's go 1 this time. So 1 squared is 1. 1 times negative 1 is negative 1. And negative 1 minus 1 is negative 2. So 1, negative 2. So look at, we're already kind of angling ourselves down. Let's go negative 1 this time. Negative 1 squared is 1. 1 times negative 1 is negative 1. And negative 1 and negative 1 makes negative 2 again. So at -1, -2. Okay, and you can already see our parabola starting to angle its way down, right? So let's put in 2 this time. 2 squared is 4 times -1. That equals -4 minus 1. That'll give us -5. So 2, -5 is right there. Okay, and hopefully you can realize here we got our axis of symmetry, right? So if we put in -2, we should end up with -5, right? -2 squared is 4. 4 times -1 is -4 minus 1, -5. So there's our symmetry again, right? Okay, see how they're just like lining up with each other, right? So that shows you your symmetry. Okay, the points are matching up. All right, so we did it right because our parabola is pointing down and our coefficient says we should have. Okay, our axis of symmetry is right there, and it lines up nice and neat. Okay, that is method 1. Okay, just kind of picking points and plugging them in and seeing what you get. So there's the first video for you guys. Hopefully that makes sense, and we'll teach you another way on the next video.